Okay, so in this tutorial, I'm basically going to be translating a tutorial by Jose Sanchez on recursion. Um, in his video, he uses the Toxi library, so he's using something called Vector 3D, which is kind of Toxi's version of PVectors. So I thought I'd just recreate the tutorial and but instead use the PVectors so you can get used to the syntax. But if you want to check this out, just Google Jose Sanchez and recursion, and you can see one of his unbelievably awesome processing tutorials. So let's go ahead and dive in. I guess, first of all, I should explain this idea of what recursion is. And in essence, it's just about this idea of repeating. Relates to fractal geometry, where we create a set of instructions and that feed that into a loop into itself. So what we're going to see here is that we're going to write a special function that that sets a point here and here, figures out what the midpoint is, and then draws a circle. And then the next time it says, okay, well, let's make the midpoint the end here, and find a midpoint and draw a circle around it. And that's what it does here. And then it says, okay, let's make this midpoint now the end point, and it just keeps doing this over and over again. So it takes the space, divides it in half, draws a circle. Takes that space, divides it in half, draws a circle. Takes that space, divides it in half, draws a circle. So this can go on and on and on, and it's one of those things also you have to be a little careful about, because if you don't write your code correctly, you can create an infinite loop and cause your machine to crash, which we don't want to do. So let's go ahead and dive into this. All right, so for starters, I've just got a basic sketch set up, nothing different here, but I am going to create a function just at the very beginning here called recursion, and I'm going to put that function up in here. All right, and let's just make sure that that works. All right, so no problems, that sketch runs. And the reason we want to do this with recursion is we want to call this function, and then eventually, I'll just show you right now that we would eventually want to do this. So we would put the function inside of itself, and if we write our code correctly, we can tell it, only do this looping 6, 7, 8 times, however many times we want to. We just want to make sure we don't let it do it infinitely, because we could cause a problem. So let's go ahead and delete that. It's one of the last things we're going to do. Let's just make sure that the instructions are correct at the very beginning. All right, so the recursion is going to require that we create some variables up at the top. What we need to do is create an endpoint on either side of the screen. Let's go ahead and run this. So what I want to do is create a point here, do a little bit of math and figure how long that distance is so I know how big to make the circle, and then figure out what the midpoint is between that and put the circle there. And then I can say, okay, go ahead and do this. And then later on we'll worry about breaking this down. So what we need to do is create 2 new p-vectors. And let's call this vector 1. And again, I'm just following, most of this is exactly like Jose Sanchez. Don't think that this is my idea for this tutorial. But it is different because he's using a different class and a different library. All right, so what I've done here is created this point here. It's at 0 on the x and halfway down the screen. And so I'll go create the other one. Vector v2 new vector. And this one will be width, because it's going to be on the other side of the screen. And again, it will be at the same height. Let's go ahead and run that, make sure we don't have any errors. All right, so that's the beginning. Now, let's go ahead and go ahead and put an ellipse in here. And this ellipse is going to have v1.x and v1.y, and that's going to be its position, and then it's going to have this variable called distance. All right, so just go ahead and copy this code for now, and let me explain what our process is going to be. So we've created these two PVectors, and we're going to want to put these inside of our function so that these values get passed into our function, and we'll use them here. So to pass these variables into our function, we need to declare what kind of data type it's going to be. So it's going to be a PVector, and we'll just call it, oops, let's make sure I spell it correctly. There, PVector, and we'll just call this v1 and v2. Now, inside of these function here, these are generics, so it doesn't really matter what I name them. Whatever I name them here, I have to use down in this script, but it's okay that I'm duplicating these variable names and these variable names. It doesn't really matter. Okay, so I could call this P1 and P2 if I wanted to. In fact, let's just do that. Let's do this as PVector1 and PVector2, and let's do the same down here, just so it's clear. All right, so this is going to be our declared variables up here, and we can say v1 and v2. Those are the variables that we're going to pass through there. We haven't named distance yet, so what we need to do is a little bit of math. All right, so this is going to be a little bit different, and as Sanchez says in his video, if you don't understand how to do some of the vector math, you should watch some of his other tutorials talking about PVectors, or consult the documentation on PVectors that Dan Schiffman has on the processing site. What we want to do is figure out the distance between two vectors, and to do that, instead of in processing normally we do distance and then we would say x1, y1, all this other stuff. If we want to do this in vector math, we could say v1 dot distance, oops, in vector, since I changed that name, pv1 distance to pv2. All right, let's see if this runs. Okay, so that's the beginning. So I have this PV1, PV2, or PV1x, PV1y. Let's change this so that we'd see that this would be, if it were 2, the ellipse would be on the other side of the screen. So what we need to do is get a midpoint between those. So we need a new vector, or new position on the screen. And let's call this midpoint. All right, so whenever we do to a new vector, let's say if I was just going to add one vector to another, I could say v1 add v2, and that would be legitimate. But this time what we want is another vector from 2. So we're going to say PVector add PV1 and PV2. And then let's copy that name. And let's see, oops, done. What did I do different here? Okay, sorry about that. Got a little distracted for a second. Okay, so we've added these vectors together. I was going to do center mode because that's what he did, but we don't need to do that. Actually, it's the default. All right, so my vector is all the way over here because I've added one to the other. What I need to do is now divide those two. Okay, because the whole thing here is that we want to get this point and find the average of those two. Because we've added both of these together, we end up with this position down here. It's just because of the way vectors are calculated. All right, so by the vectors, so we just say midpoint multiply 0.5. All right, so that gives us ellipse right in the center. And let's go ahead and say no fill. Okay, so we're almost there. The last thing we need to do, and this is the very important step, is set up a limit for the recursions. So we're going to need to pass a variable into here so that we can tell it how many times to do this. So let's say 6 times. Again, this is what I'm just following along with from what of the numbers that Jose used in his tutorial. This could be any number. And we need to declare a data type, integer, and he calls it iterations. Seems like a good enough name. So we're passing that in there, and then we need to say if iterations is less than or is greater than 0, we'll do a little countdown. Then do all this stuff. Okay, and there's one more thing we want to add. All right, so now we're going to add the function itself, recursion. So this time we're going to say PV1 is the start point, and then midpoint is going to be the beginning end point, and the midpoint is going to continually change and get shorter and shorter. And then the last thing is we want iterations minus 1. So whatever iterations is, let's go ahead and decrease it by 1. So that way we start with 6, we go through, it does this command, and then it does recursion again, but this time knocks it down 1. So then it's 5, then it's 4, then it's 3, then it's 2, then it's 1, then it's 0. If it's 0, it will stop. So hopefully I've done everything correctly. Let's make sure, let's see, we don't have any errors. And you can see there is our little circles. Let me put smooth on. There we go. And let's go ahead and copy into this one again. But this time let's do it from the other direction. Let's do it from the PV2. All right. And if we want to get ridiculous, let's make this like 8. Right? So you can see this can go on and on and on. And this is where we start to get ideas of self-similarity within fractals. Right? So recursion is very much related to fractal processes. If that's something you're interested in, check that out. Check out Jose's video, which is really fantastic. All this is based on his, but I wanted to do it in PVectors. Hope that helps.